to another Daishinfinity video. In this video we're going to talk about the Periphery Angle Theorem. This is going to be the proof of the second one. The first video was talking about the equal equation that gamma 1 is equal to gamma 2 and that it doesn't really matter where C1 and C2 is inside of the segment AB. In this video I'm going to talk about the theta, and I'm going to prove that theta is the doubled amount of any gamma 1, gamma 2 or gamma n. Now to prove this we have to take a look at the first example. Let's take gamma 1 for the degree at C1. So we would have this four-sided figure C1a, m and b. Now in this four-sided figure we have this four-sided figure a, b, c1 and m. So this is element of the circle O. I'm going to call it O. Now if we talk about the degrees or the angles, the angle at the point A is going to be alpha, the angle at the point B was going to be beta, the angle at the point C1 is going to be gamma 1, and the angle of the point M, which looks down like this, is let's say theta, for example. Now the trick in doing this is I'm going to split this figure into two smaller triangles, which means I would have this kind of thing. And if we look at the sides of every single side of this figure, I would see that I would have the radius from M to A. So let's say the radius MA is radius, but the radius is also M to B, and the radius also from M to C1. So we can write radius here, and radius here. So we have a lot of information over here already, even though if I only wrote R. But since we have a triangle at one side, let's call the triangle AC1M. So I'm going to call the triangle AC1M in red. So AC1M is the triangle 1, and let's call BC1M. Sorry, not B. BC1M triangle number 2. So this is triangle number 1. This is triangle number 2. Okay. Now let's talk about the degrees we have, or the angles. The angle is over here, theta. Now let's talk about these two angles. Let's call them epsilon 1 and epsilon 2. So let's call this epsilon 1 and let's call it epsilon 2. Okay, very nice. Now since I had the gamma 1 over here, I'm going to split it up in gamma A, capital A, and gamma capital B, so that we have two smaller angles. So here we have gamma A capital, and we have here gamma capital B. Very nice. And then we have alpha and beta. But since we have a triangle which has the same sides R and R, as you see here, I'm going to draw the same triangle on the bottom. Since we have two same sides, the angle over here, which is also called the basis angles, are going to be the same. So let's call this alpha, for example. But in this example, we would have gamma capital A, since I wrote gamma capital A at the top. So this is also going to be gamma capital A. Sorry, not Y capital A, it's going to be gamma capital A. And the same thing happens for gamma capital B, because we also have the radius. So this is also going to be gamma capital B. Now, to consider, we can write a formula or an equation according to theta, epsilon 1 and epsilon 2, because if we make a full turn, it's 360 degrees. So we can write for the Roman numeral 1 that theta plus epsilon 1 plus epsilon 2 is going to equal 360 degrees. Now the second equation is going to equal that gamma 1 plus gamma capital A plus gamma capital A plus epsilon 1 is 180 degrees. This comes from the triangle that the three triangles, the inner sum of the three angles in a triangle is always 180 degrees, and we have gamma A and gamma A and epsilon 1. We can do the same thing for the third equation, that we say gamma capital B plus gamma capital B plus epsilon 2 is also equal to 180 degrees. Since we have these two equations 2 and 3, and the first equation has 360 degrees, we could actually add these two equations up. So we would do 2 plus 3, and which will get us to 360 degrees. So that we have a very long equation which we can manipulate and get our answer to. Since I said that, I'm going to add these two up. So I have 2 gamma A plus epsilon 1 plus 2 gamma B plus epsilon 2. Now the first equation was theta plus epsilon 1 plus epsilon 2. Now since this here is 180 and this here is 180, and we are adding these up, and this is 360, we get 360 is 360, in which we can write an equation. So we can write an equal sign to it. Now if you see over here on the left and the right hand side, we both have epsilon 1 and epsilon 2, so we can cancel them out. And then we have that theta, I'm going to write theta over here, is equal to 2 times gamma capital A plus 2 times gamma capital B. To simplify, I'm going to put the 2 outside and put a parenthesis on it. So theta is going to be 2 times gamma A plus gamma B. So this is what we got, and I would like to simplify it one more time until we get a final answer. Since we talked about gamma A and gamma B, when we add these two up, we would have this angle over here, and this angle is on C1 and A and B. And since C1, A, B and M are in a circle, we can say that the angle on C1 is gamma. And we talked about it that gamma A and gamma B are gamma 1. So gamma A and gamma B together added up, the sum of it is gamma 1. So in the last equation, we can just say that theta is 2 times gamma 1, or for any gammas we have between the circle segments. So it can also be 2 times gamma 2 or 2 times gamma n, for n being a natural number, which is positive, so not equaling 0. Very good. So now we have a general form of theta, and we have proven that theta is the doubled amount of the angle of gamma 1 and gamma 2, and in general gamma n. I hope you liked this video. Leave a thumbs up, comment on the video, ask some questions, and I'll answer them. Very nice. Thank you for watching, and see you in the next Daishinfinity video. See ya.